Hello and welcome everyone to today's workshop on machine learning on OCI for League of Legends model building with scikit-learn and AutoGluon. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. We're excited to dive deep into AutoML tools that can make developing AI ML models much easier from the developer's point of view. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits so that you can try out the services and follow along with the lab steps today. We'll go over the steps to get started in just a minute. We'll also be recording the session, so if you'd like to complete the lab later on, we'll be sending the link to the recording via email shortly after the workshop concludes. If you have any questions during the workshop, please ask them in the Slack channel and we will answer them throughout the session. The link to join is bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there, you can search for Lab League of Legends to reach our dedicated space for Q&A today. Today's workshop will be presented by Ignacio Martinez, Data Scientist Advocate, and Victor Martin, Technology Product Strategy Director. You can access the lab guide by following this link here, and I've placed it in the Slack channel and we'll drop it in the chat again in just a moment. And before I turn it over to Nacho, we'll begin with a short clip presented by Victor on how to set up your cloud account.
Hi, I'm Victor Martin from Oracle Cloud. I'm going to walk you through the steps to sign up for an Oracle Cloud free tier. Please follow along and pause the video when you need it. Oracle Cloud free tier gives you a set of always free cloud services. These services will be available forever. 2 autonomous databases, 2 virtual machines, up to 4 ARM processors virtual machines. You will also have a load balancer, block, object, and archive storage, monitoring, and much more. As part of your Oracle Cloud free tier, you will also have a 30-day trial with free credits to use in other services from analytics to Kubernetes. Sounds good, isn't it? Are you signing up for an upcoming workshop with us? Please make sure that you use the same email you use for the registration, as we have activated a special offer and you won't need your credit card to sign up. In any case, Oracle Cloud is not going to charge you for your trial. You actually have to explicitly tell us so when you are happy with all the Oracle Cloud services after your trial. Let's dive in. You need to add your country, then your first and last name. You also have to provide your email. Oracle Cloud has to check you are a human by asking you to resolve an easy challenge. Finally, click Verify my email to move to the next step. If your email has been activated for the offer, you will see the special Oracle offer pop-up window with the type of offer already selected. Then click Select Offer. All the initial information is already in. Now you have to provide a strong password. I use a generated one, but you can select any you like. Just make sure you are in compliance with the strong password pattern. Confirm the password by typing it again. Fill the company name if apply. The cloud account name is essential as it is a unique identifier for your account. Select a name you like that is not taken. The home region is the region where you are more likely to deploy resources. You can deploy to other regions by subscribing to them. However, your free trial only supports one region. Select a region geographically close to you if you are not sure. I'm selecting Frankfurt region. At the bottom, click Continue. Fill the address information with city, postcode, county, and your phone number. Click Continue. The final step is to accept the agreement and click Start my free trial. Oracle Cloud starts provisioning your account. This takes on average 1 minute or 2. Then you are going to be redirected to the Oracle Cloud web console. Can you see the message "Your account is currently being set up"? It means that some services will still be unavailable for a few more minutes. Just keep it in mind. When Oracle Cloud fully provisions your account, you will receive an email. I will show you that in a few seconds. Go to the menu to explore Oracle Cloud services. Also, the search bar is a friendly tool as you can search for compute instances, Kubernetes engine, analytics services, cost tools, user management, autonomous databases, Apex instances, and much more. On the right side, you will see the region you selected when you sign up. The next icon is Cloud Shell, a small free Linux instance with several tools pre-installed and configured like OCI CLI and languages like Java, Node, Python, and more. You can close Cloud Shell now, confirm with exit. The next one is Announcements for updates from Oracle Cloud. The following is the Help icon, where you can find documentation links, chat with us, post questions in our forums, and finally, create a support request and request a limit increase. The next icon is to change the language, and the final one is the Profile icon, where you can see your user information, your tenancy, and the Sign Out button. After a while, the message saying that your account is being set up will disappear. After a few minutes, you will also receive a Getting Started email and another one when your trial account is fully provisioned. Use the button in the email to sign in whenever you want in the future. You are all set up to enjoy your new Oracle Cloud account. Happy hacking!
All right, and with that, I will hand it over to Nacho.
So welcome everyone. I mean, we planned this workshop to be around 2 hours. I think we're gonna be a little early in time, so you're gonna get a couple minutes back afterwards. And the main idea today is, to get started and keep doing the things that we were doing on the first workshop. I don't know how many of you have assisted the first one that we did on the September 28th and 29th. But I mean, it's okay. I'm gonna try to explain everything as simply as possible so that, I mean, if you didn't assist the first one, then you can still follow along on this one. And we're gonna focus specifically on things like scikit-learn and AutoGluon. AutoGluon is a open source tool created by Amazon that simplifies, the machine learning process a whole lot. And we're going to see, how we can exploit these kinds of libraries to our advantage without, overcomplicating the problems that we're trying to solve. So first thing I want to say is that, yes, you heard that correctly. It's $300 for free. So you should register to Cloud if you haven't. And yeah, let's get started. So this is the link that you should see whenever you click on the link that I sent through chat. It says the lab guide 1109. This first chapter, this getting started chapter, is just going to be about the things that Victor has explained in the video. So if you have missed any of the steps, then you can just go back here and register to OCI. And yeah, so I would like to give an introduction. I don't know how many of you play League of Legends. I know some people in chat that are from that are coming from LinkedIn, also from private Discord communities. So I think that today we have a couple more people that usually play League of Legends, I would say. So yeah, just to give an introduction on the things that we're gonna see here in this workshop. In the past, we have created a very simple, very simple problem with scikit-learn and with pandas on the first workshop, and it was a good model, but it had about a 51% accuracy for a classification problem. So it wasn't really the best model that you could find. And what we're going to do today is to try to improve or create another model that, instead of considering just the most simple variables that could be considered, we're just going to consider many more variables, see their correlations and stuff, and see how they can be useful for us in our model. The idea is to create a couple models for League of Legends. This is, for example, one of the post-match screens that you would find after playing a League of Legends match. And you see that we have hundreds and hundreds of statistics that we can select and filter out and get. And this information is also available not only through the user interface after you finish a match, but you can actually get this information from an API as well. And the dataset we're going to use today, which is already generated for you guys, this dataset has been previously generated with data that has been obtained through the API from hundreds and hundreds of games. We have mine data, which is what I was talking about. We're going to have a dataset of about 1.2 million rows, so about 600,000 matches. And all these matches have been specifically selected, and they are matches that have been played by Masters players, Grandmaster players, and Challenger players. And this is very important because if we had considered, matches from any player, then our model would be completely biased because it would be affected by the human factor, and we want to remove these kinds of things, from our problems. So yeah, well, I mean, the idea is to create a more advanced machine learning model for League of Legends today. The two main pillars of this hands-on lab are going to be just to create an offline model. And what I mean by offline model is one that's able to make and has been trained on historical data and is able to predict more or less how well you're doing after a match. This model just works offline. So you couldn't apply this model in the middle of a game because we would only have information after the match. So for example, this would be one of the data structures that you could find in this JSON object that I'm trying to explain. So for example, for a Brazilian match, you see here that you have a match ID with a BR, that would be the region, then a match identifier, and then the lane that the player has played in. And just be mindful that League of Legends doesn't actually give you this information like this, but we have processed it in some way. And after that, I mean, you would have two objects, two enemies, the two bottom players, the two AD carries. You would have, all the stats after the fact, after playing the match. And afterwards, then we're going to have another model, which the whole concept is to apply this in real time, and we're going to go through a practical example on how to create an online model, how to deploy it in real time, how to use it in a Python script or something. And I'm just going to demonstrate in a League of Legends match if we have the time, which I think I will. And the structure is kind of similar, but it doesn't give you the same information that it gave you before. So you wouldn't have, for example, the number of kills, number of assists, number of deaths. You would be more focused on the champion statistics. So for example, it would tell you the ability power, the attack damage, armor penetration, etc., etc. And just be mindful that many of these variables we're going to have to take out. We'll see why in a few minutes. We're going to work specifically. This project is going to be around data science, and we have also included here a Cloud Shell and compute instances and an autonomous database. The thing is that usually the deployment on the first workshop, we did that through Terraform with some scripts, but I'd like to change that today because it's much simpler, just to show you that what you can do through the OCI console. Yeah, so I mean, I want this to be a workshop where you're not bored or anything. So if you have any questions, just please leave them in chat. Try to have this be more dynamic than usual. So yeah, let's get started with the infrastructure part. And since we're not going to deploy it today with Terraform, let's just skip through to the task number 5, probably. Well, task number 4. Okay, we're just going to create. I've already done this. I'll explain why. But I've created a project since all the setup takes a while. Let's just wait a couple minutes before getting started, as people are still registering for OCI, I see. Laila, if you have any questions, just leave them in chat. I see that you raised your hand. So the basic thing that I'm going to do right now is just to create a data science project. I'm going to create a new project for this. And the purpose is just to create a data science environment so that I can work on this League of Legends project, right? So I'm just going to do League of Legends project. And, you know, I want to do this as soon as possible because the deployment usually takes a couple minutes. So I don't want to waste a lot of time afterwards. So now I would just have to, you know, my session, whatever, you can put whichever name. I'll just put, you know, 2.4. 2.4 means we have 4 processors and 60 gigs of RAM, which is more than enough for the things that we're doing. I don't know if you can actually choose graphical processing units for the free trial, but if anyone has credits, then you're welcome to do that. And I'm just going to create this. So, I mean, you know, since this project creation and this notebook session creation takes a while, that's why I already did that in another notebook. So we could just, this would be, you know, it tells you that, you know, the data science notebooks is active at the moment. And I'm just going to join this one. But this is the thing that you get, you know, after deploying in a couple minutes. Yeah, usually here you get like a session that takes, let me zoom in a little bit. It's you can extend your session if you're gonna do, you know, some extra work, because if the session dies, then you get disconnected. So let's see, I think I already have this here. And yeah, let's go to the task 5. Okay, we need to load the notebooks, set up the environment and everything. We're going to use a terminal for this. So let me, if we do this, I just open a new terminal and I said, okay, I'm going to clone here. Let's see if the other one is already finished. Yeah, it's finished. So yeah, I'll just access the first one so that you can see what I'm doing. Okay, so we are in the, you know, task number 5. First thing we need to do is just to open a terminal, like I said. And now we're here. This is just a standard Linux operating system, okay? And first thing I'm gonna do is just clone the repo. This contains all the source code that we're gonna use today. So I just clone this, and it's gonna copy everything into, you know, locally. Then I'm gonna install a Conda environment. And a Conda environment and ODSCs, this is just an Oracle data science Conda. This gives us, you know, some additional libraries to access, like Oracle AutoML and other specific libraries that are good for us. This is necessary for us because once we create a Conda environment, Conda is a package manager for Python, if you don't know. We can specify different environments, and we can tell, okay, I want this environment to only have the libraries that I need to execute my Red Bull project, or I need a League of Legends Conda environment, and this allows you, you know, for some isolation on your behalf. Yeah, so this takes a while, you know, activating the metadata for this. This is the most long-lasting one. So yeah, let's just wait until this works. Tushar, you said, are there recorded sessions for other ML with OCI which we can see? Is there a direct link link to the list. Yes, we have the Oracle developers YouTube channel that you can check out. But I'm sure Tara can tell you more information about that. Yeah, don't worry, Darren. You see that in my notebook session, it says still reading the notebook. I know it takes like a couple minutes, but I think we're gonna catch up pretty soon because this also takes a couple minutes to execute. I mean, just as a reminder, you can just access data science like this. You go into the projects, and whichever project you have selected. Now I don't know which one I did. I did this one. Just open the notebook once it's ready. Okay. And you know, the following process just after creating this conda environment would just be to activate the environment. So after we have created it, then we can just activate it so that it's present for us, and then we can make some modifications. And the thing is that we're going to use Python 3.8 for this, so we need to install it into conda, because conda by default I think has Python 3.7 right now. So you need to specify which Python version you specifically want for that package or for that isolated collection of packages. And afterwards, then we're just going to take one of the files that you can find in the open source GitHub repo, which is r2.txt, and this contains the list of requirements for the project that we're going to do. Fernando says, what is the trial code for the creation of the account? You should the free trial code. Yeah, one of my friends will help you. Okay, and this has started to take some shape. We're still downloading, you know, some dependencies that it needs. But be mindful just that these dependencies don't have to do anything. Don't have anything to do with our project. We still have to download the requirements that we need, and they are here. So we're just going to use pandas profiling for data visualization. We're actually going to use AutoGluon for building the models, and you know, I have a couple surprises for the end. So if everyone is kind of following me, I would just have to, you know, install this Python afterwards, and then this is just 2 commands to execute in the terminal after all of this is done. Looks like it's almost done, so I'm just gonna copy this. Yeah, so it's done right now. So I'm just gonna clear the terminal, and I'm gonna activate the environment. Okay, so now that you see that now my conda environment, my Python environment is depends on this conda directory that we have created. So now I'm just going to install Python 3.8 in the meantime. And this is going to actually use the conda installer from the directory of our new environment, which is actually what we want. And yeah, we're going to use Python 3.8. This code is already done, so I'm just going to install now the dependency that we need. And this takes a while because you know that you see that some of these packages are almost like a gigabyte big. So I'm just going to skip this, and I'm going to open my other session, which has already done all of this, I believe, if I did that correctly. And if not, let's just go back afterwards. But you know, let's just go to accessing our notebook. So now that you see here in the File Explorer, you will have your conda environments, and then you will see this League of Legends optimizer. This is the name of the GitHub repo, in case if anyone is interested in actually looking at the source code that we've done. And here you have a lot of things. We're just going to access the notebooks part. And here you have actually all the development efforts that are being done for this workshop series. We also have a third hands-on lab, which is upcoming in the upcoming months. We don't know for sure yet, but it's 100% coming. We're going to use this applied AutoML notebook here. I'm just going to open it. And, it tells you, okay, which kernel should I execute this with? And since we have created this myconda v10 environment, this is the one that has our dependencies installed on everything. And this is the one that we should use. Now, I've seen here that before I've done all these installations here, I didn't select the proper one. So I created the conda environment, but afterwards I installed Python and the requirements in the base environment. So in my case, it would be ideal just to use the root environment. And if there are any problems with this, then I'll just skip to the other data science session. But just be mindful that you can select different kernels and different conda environments here so that you can execute, different things at the same time in one environment or one machine. That's the purpose of conda. So yeah, I don't want to be hesitant. So if there are no further questions in chat, let's just begin with this model improvement with AutoGluon. Okay, so in this past workshop, we created a very simple model. Like I said, there are hundreds of ways in which you can actually improve a model, but I've decided to work on improving a little bit the data set, so generating more data than the ones that we had on the first hands-on lab. We're going to talk about hundreds of ways, but the thing is that we're going to create a model that considers all the variables in the data structure that we have seen. So this structure, we're going to try to consider all the variables, and we're going to start off with the offline data set. You will see that many of the things that we see on this offline data set code can actually be duplicated or reproduced again. And much of the code from the online dataset part is very similar to the one here. So for each match, we will have 5 matchups. Okay, since in League of Legends you have 5 players against 5 players, then you will have 5 different lanes or roles that will be fulfilled. And these are the basic statistics that we can work with. Yeah, so let me execute this, and I'll see if this returns any errors right now. If this returns any errors, then I'll just go back to the other one. Looks like it's fine. So I'm just going to execute this. Yeah, it doesn't find. Oh, yeah, I forgot. My bad. We need to, here it's asking for a home data science datasets and matchups.json. We haven't yet downloaded the dataset, right? We only have, here we only have the League of Legends optimizer code and our conda environment, but we're still missing, the datasets, which is task 6. I forgot about this. So what we need to do is just go back into the terminal. And we're just going to copy this very nasty command with a lot of capital letters, and we're just going to paste it in our environment again. And this is basically just going to get some information from OCI object storage, which is a great storage mechanism. It's the cheapest one from the top 5 cloud competitors. It's like 10 times cheaper. And right now it's downloaded a zip file. It's inflating it, so it's decompressing it. And within this this zip file, we have a datasets directory now, which is the one that contains the dataset that we're going to use. So now if I try to execute this again, now it's going to find the proper path for this matchups.json object. And just remember that these files are pretty big as well. So this takes a while. So don't worry, don't worry about. I'm just gonna start running this. Well, we have some time. And I'm just gonna execute the first part since some of these things takes a while. And I'm just gonna start talking. So that you can see here. I have my applied AutoML here on my other project. And I'm just gonna select this one. And here, we're not able to see this yet. That's why I wanted to execute this. This takes a while. It creates an HTML report that allows us, to do all the usual exploratory data analysis work just by, generating a report that you can specify and stuff. This is going to be really good for us. So if everyone has created their data science, their data science project and everything, yeah, so this will take about 5 minutes, probably a little less. And this profile report just comes from Pandas profiling, which is the thing that we're going to use. Let's go back to the lab guide so that you can see how we're doing. So basically, we set up the data science environment, we downloaded the data sets, we access the data sets, and of course, important thing is to select the specific environment that you want to, which Conda environment you want the notebook to run on. And then we're just getting started on lab 3. And doing the dataset analysis first, we can just load a JSON file. And this orient equal to records means, orient records means that you can actually change back the JSON structure to a tabular format, yeah. So afterwards, we're just gonna generate a profile report. It's almost done, but you can see more or less the things that we're gonna have in this profile report here. So we're just gonna have like an explorer, and we're gonna see all the things that this offers. But basically, we're just gonna have 13 variables, 2.4 million observations, so 1.2 million matches. Well, 2.4 million. We said we were going to have 5 matchups per match, so we would have 500 matches, more or less. Yes. And we're also, able to, see all the data types, missing values, and also this correlation coefficient, the Pearson's R, which it's a value that is between 1 and -1. If a variable doesn't have anything to do with another variable, the correlation is going to be closer to -1. And if they're very tightly correlated, they're going to be equal to 1. Of course, you see that this diagonal is always at 1 because we're comparing a variable number 1 with variable number 1. So of course, this variable gold earned has 100% correlation with itself. And this is what happens, on this diagonal. This is why this behavior is expected. For example, here we see that there's a high correlation between the number of kills and the amount of gold that people earns, also the number of assists and the vision score. And yeah, we can start seeing some correlations here just to give us an idea of what things are important or can be inferred from other things. Like, of course, if you get a lot of kills, then the most direct repercussion of that is getting gold, right? This is just from League of Legends. Yeah, so while this finishes, although we have already seen this, the code editor won't start in Ashburn, Michael. Just as a reminder, you don't need a code editor for this because we're not deploying through Terraform like we did on the previous Hansa lab. You can just deploy through the console. So you can just go to data science and create an environment by yourself. Yeah, going back to what we were saying. This is at 92%. I'm very tempted to wait and just see if everyone is okay. Okay. Summary is done. And now it's going to generate a report structure. But the main thing that we're going to do here is just look at the data for a while. Like this. Okay, this is perfect. This is what we get. Okay, this is an interactive HTML report. We get a lot of statistics, also the file size as well. And we can see, for example, the match ID, we see here that it tells us, oh, this variable has high cardinality. What's that mean? That means that high cardinality means that the number of possible different values are very high. So it tells you that 50% of these values are different, because we're going to have one identifier for 2 players, but this identifier is never going to be the same compared to other rows of data, right? It's also very uniform. Of course, it's uniform. It's always strings. They have a very similar length. So yeah, I mean, this variable, I'm spoiling you, but this variable is not really useful for us in any way, because it's an identifier, and identifying variables don't add anything to the model. Yes, Jose, this is live. I'm talking live. Yeah, don't worry. Yeah, so we can see this, the distributions, of course, for each one of the variables. You see that this one is very has a normal distribution, but it's a little bit skewed to the left. And also here on the alerts part, this is my favorite part of the report. It tells you the variables that are actually good and the ones that are not good. So any variable in machine learning with a very high cardinality, if it's not really intended to be or to have so many values, then this is not a good sign. So this is probably not a good variable. A champion, for example, is not so bad, because from 2.4 million rows that we have 156 distinct values, which is not bad at all. But for example, we can't have 450,000 different values in one column, because this would be like 20% of all values are different. So this is another identifying variable that is going to go to the trash after we delete it or not use it. And the summoner name also has like 505,000 different values, which is crazy. So this is just 5 examples of the things that we can expect. We print out the columns, and of course we have 13 variables. Some of these variables are going to be numerical, and some of these are going to be categorical. And what I mean by categorical is just words like this. We're going to have to get rid of this or make some transformation. We'll see how to do that. We get some stats from pandas. So if you're not a very fancy person and then you just want to use pandas for visualization, just be mindful that the describe function doesn't consider any information for the variables that are not numerical. So here you will only find the variables that are numerical in the dataset. So you also need to remember that you have other variables that are actually not here right now, but you need to take care of them. Okay. And yeah, I mean, the mean and the standard deviation is something that I always look at, because if the variables have, for example, a standard deviation equal to 1, for example, this means that each row value is going to be different. So you can infer some things from this, just to give you an idea of what the column contains. It also tells you the minimum amount In some cases, like for example, it makes no sense to have a negative number for damage or health. It doesn't make sense to have a negative number here. So probably one of these values are probably bugged out, and they will returned by the League of Legends API incorrectly. You know, I can assure you, because we have done some analysis on this data set, that this is very negligible. So probably like 0.01% of all rows are affected by these bugs. Prerequisite sessions. John Ford says, are there any prerequisite sessions that may help us break into machine learning for absolute beginners? Don't worry if you think this is too advanced. You have here, let me show you here in the getting started, I think, no, in the introduction, you also have a link to the first workshop here. And this explains, you know, the things that we're working with in much more detail. You know, it has the same structure on this, but we explain all the machine learning concepts briefly and very concisely. So I think that will be good for you, John. And yeah, so what things did we say up till now? We need to remove the variables that have a very high cardinality and the variables that are identifying variables, which are usually the same thing. So if we remember here, it said that the match ID, the player unique identifier, the summoner name have more than 400,000 values distinct for each other. So I took the liberty to create this drop column function, and this will take a data frame as a parameter and a list of columns. And for each one of the column names, I'm just going to drop this in place. So this is going to, you know, change the value by reference. And I'm just going to return the new data set. So the data frame, I'm just going to do this. And I'm going to tell my function to remove these 3 variables that I didn't want. After, will you send, Yusuf says, will you send recorded session? Yes, you will receive a recording of this, don't worry. And if you have any questions, you know, just make use of me. I mean, I'm here trying to help you guys get started into OCI and machine learning. So any questions, like, don't hesitate to ask me or interrupt me. Okay, so after we have dropped these columns, I'm just going to perform a 80-20% train test split. And the idea with this is just to split the data set into a part that's going to be used for training and one part that's usually smaller that's going to be used for validation. So if my data set has 2.4 million rows, then 480,000 of these rows will go just to validate if the model has been accurately trained. And the remaining 1.9 million rows is going to go for training the model. So this is the fraction that I choose. And I'm just specifying a random state of 200. You can just put any number here. I like 777 for luck. I usually put 777, but I didn't want to be superstitious today. So after performing this 80-20% train test split, I look at the data, which shouldn't have changed at all because we haven't done anything with the data. We have just divided the number of rows. That's it. And now we start working with the things that are really cool. So yeah, here I put a link for the official documentation. But the idea is to use AutoGluon for things that are usually, or things that usually take a lot of time or effort whenever you're getting started on machine learning. And I love AutoML tools because they do most of the work for you. You just need to focus on the data. So yeah, I'm just creating here a tabular dataset object with the data frame, and I'm just changing, since this is Python and we can do whatever we want because Python is crazy. We can just change the type of the data frame to a tabular dataset. So now it's not a pandas object. Now it's going to be an extended pandas object. that has a different type. And the only thing that I need to do is, if you remember, we have this data set here. I have this variable, which is the one that I want to predict, right? I want to know if I'm winning or I'm losing. That's the whole idea. So this win variable, which is either false or true, I'm just going to specify this to be my target variable. And my target variable, or my label, some people call that. I like using target because this is the thing that I'm looking for on the solution. This is what I want my machine learning model to predict. I'm just going to specify this win variable to be the thing that I want to predict. Okay. So that's what I do here. I just say my label equals the number of the name of the variable, and just if you want to do some additional predictions, you can specify for the future several variables. If you want to predict 2 of them at the same time, then you can do that. Just specify a list here. I'm just gonna create a tabular predictor, and then I'm saying, okay, please save all the things that you're doing, and this is gonna create we're gonna go through this, but this is gonna create a directory, and this directory is gonna have where was this in notebooks? So this creates a lot of things. The models, it creates a directory for each one of the models that it's trained. It's already trained them. And these are pickled files, which are encrypted, so we don't know exactly what's in them. But we know for sure that if we import this model afterwards, and this is what we're doing here, this is going to work. So, I mean, what more could you possibly ask in a machine learning model that you don't even have to do all the things that we did on the first workshop? I don't know if you remember, guys, but we spent like 50% or 60% of the 2 hours just modifying variables. So we had to convert all the strings. We had to convert them in some way, in one way or the other. We had to convert them to numbers because, I mean, the computer only understands numbers. So we wasted. I mean, it wasn't a waste because we learned, of course, but we wasted an hour of our time. And this, you can do that with 4 lines of code. All the things that we did before, you can do with 4 lines of code. And you can actually specify the number of seconds that you want each one of the models to be trained for. So if you want a really good model, then you can specify here like a crazy time limit so that the model is fit until the end. There's never an end, but you can just put here like, I want my model to be trained for a day or for 60 seconds. Just for simplicity, and since this is a proof of concept, I said, okay, I only want each one of my models to be trained for 60 seconds, and the result will be the result that I get. And here you see that the preprocessors and everything from AutoGluon, it infers some information. If you don't tell it explicitly, then, for example, it assumes very correctly in this case that our prediction problem is binary because we only have a false or a true value in our win variable in the dataset. So we either have a true or false. You can, of course, specify if this is not the correct problem type, then you can just say it with this problem type parameter. A binary multiclass. You would use multiclass if you wanted to predict more than 2 categories. So if you have, for example, I want 5 categories and I want to predict in which bucket this is going to go, I don't know. And regression will just be for continuous numbers, so numbers that are not integers. And this is basically just going to train. It generates, it fills invalid numbers, it changes some features into a way that the computer understands. And after all of this, then it just returns this directory that I showed you. And what is the recommended spec to run on a laptop? Darren, the good thing about this is that you don't even need recommended specs, because if you're running this on the cloud, you're not using your computer's resources, right? You are just using your browser to connect to the data science session. So you're actually using you're using Oracle Cloud machines that are, I don't know, Frankfurt or whichever region you have selected, and you're using those computers for solving problems. So I mean, you can work with Windows 97 and it will still work if you have a good browser like Google Chrome or Firefox. If everything is really slow, maybe try to open like an incognito browser. Maybe it's better for you. But and I'll also be mindful of your internet connection, because since all of this you're connecting remotely to a machine. Like right now we are connected to a machine, believe it or not. If you have a really poor connection, then you might have some throttling issues. Yeah. Okay, so after we have loaded the model, and we've saved it here, right? What I wanted to illustrate here is that if you don't use this predictor object, I'm just overriding this predictor object with the load function, and the load function allows me to get my model into the code independently or without any precondition on the code. So I just need to import AutoGluon and then just load this, and this is going to work on any computer. And this is how we're going to export the model afterwards. And now we're just I'm just doing this code just to make some predictions. And these are the predictions that are returned. And you see here that the best performing model has 81% accuracy. And you would say, whoa, 81% accuracy, then this is crazy. Like we're almost done, right? Well, the machine learning process is never done. I want to show that, you know, you have 81% accuracy here, but this model can always be improved. And this accuracy just means that the model works well on the test data that we have given it, right? But this is sometimes not the solution or not the real accuracy, because I mean, you could have some test data that is very different from the real world. So once you deploy the model, you don't even have to look at this metric. You need to see how it performs in the real world, and that's what we're going to see in a couple minutes. And now the leaderboard, it tells you the best performing models in order. The light GBM, which is light gradient boosted model. We have weighted ensemble and stuff. But the thing that I want you to understand from this is that you have some models and then you have some accuracies, but these are not the only things that you need to consider. I always look for this spread time value, which is the prediction, the time that it would take for the model to make a new prediction, which is 0.16 seconds. And this is actually great. I always look at this metric because I don't want my models to be, I would much rather have a model with 81% accuracy and a 0.16 second prediction time than a model with 99% accuracy and 15 seconds on prediction. I don't want my model to be perfect. I also want it to be fast, right? So by looking at this, the best model, of course, is the first one, right? It has the highest accuracy and the lowest prediction time. So this is the model we're going to stick with. We're going to use light GPM, the model that has been trained for us. And here I'm also printing some feature importances. So I'm asking my model, which are the variables that you found out to be the most crucial when making these changes or these predictions. So it says that the most determining factor in League of Legends is the number of deaths. If you die a lot, then you're probably going to lose. And it makes this distinction here. It says that 17% of the model is based off of deaths. 11% is about assists, 6.3% is about gold earned, 1.9% is about kills, and some other things. Of course, if you increase the subsample size, it's gonna return more accurate results. And also, you see that all these feature importances don't actually sum up to 100. That's because probably we haven't trained the model enough, so that right now it knows that some variables are good, but it doesn't know how crucial they are. And you can change that by just specifying, giving the model more time to train, right? We just gave it 60 seconds before, and we want some extra time. And what I wanted to show here is that I created like a fake data point from League of Legends, just like you would obtain in a match. I'm creating a new data frame with the column names, and I'm just passing this whole test data frame through the model's pipeline so that I can make a prediction. And after making this prediction, I just return the prediction probabilities. A prediction probability, it illustrates the amount or the probability or how sure the model is of any prediction. So for example, if I have, it's predicting that I'm gonna lose, right? Name is 0. So this means that the model, it's telling me, okay, it's 77% sure that I'm gonna lose this game as Jace. If I have, at any point, I have these statistics here. 5,000 gold is not so much, actually. So this is the whole process, right? We've done all the things that we did in the last workshop in an hour, more or less. Our model is actually, it has like 30% extra accuracy, which is absolutely crazy to think about. And the code is about 3 times smaller, if you recall what we talked about. And now with this process, I would like to apply this again to a live client dataset instead of an offline dataset, because the live client dataset, live client is an API, is a way to extract information from League of Legends, and it through this API I can get real-time information from my games. So what I want to do is like to create this live companion that helps me throughout games and tells me, okay, I'm doing really good, I'm actually doing badly, I need to, step up my game if I want to win this game, etc., etc. And yeah, instead of training the model with the things that we did before, like for example, the number of deaths, number of assists, we're not going to have this information in real time, but we do have some champion statistics or some information about our hero in real time, like the attack damage, the armor, the number of items that we have, tenacity, physical vamp, etc., etc. So I want to reuse most of this code. I'm not going to go through that again. Let me execute this though, so that you can see the HTML report for the variables on this model. And let me see. No, I don't have this. Yeah, I wanted to see if we'll go back to this, okay, after. But the thing is that instead of using a JSON object now, we're just going to use or load a CSV file. And with this CSV file, I'm just going to generate another profile report just to see relationships, which variables have a really high cardinality, etc., etc. And just to show you, the kind of things that we can expect from this data set. I'm just displaying here the first 5 rows that we have. We're also going to want to predict this winner variable, which is also going to be a 0 or a 1 or a true false. So this is going to be a binary classification problem as well. You could, of course, you could, and one of my suggestions after this hands-on lab is to create your own model, but a regression model. And the hardest part is to find a statistic that tells you, oh, this is a good way, instead of having a winner here, just calculate like a performance statistic that tells you, oh, you did like 81% as well as you would be expected. But that's one challenge, just to get a formula that works in many cases in League of Legends that tells you, your performance stats. But yeah, see here that the data is very different. We have magic resist, the health regeneration rate, and we also have some identifiers. And these identifiers, just very quick quiz if you wanna answer in your head. What do you do with identifiers if they have a really high cardinality? You throw them on the garbage, and that's what we're gonna do. Yeah, so I mean, we have many more variables than before. And we're gonna, see how to work with this. Just as a spoiler, all the identifying variables are just gonna go out of the model. We have many more variables, and just remember that this winner variable is the one that we're gonna try to predict. So depending on how well you're doing, my assumption is, okay, if I am doing very poorly, then I'm not gonna have a lot of stats compared to a player that's doing very well. So my armor is gonna be small. I mean, I'm gonna have fewer armor than him. I'm just gonna have less movement speed, less spell bump in most cases. And since we're also giving it the champion name, then we have some, we have some additional information. So that's what we're gonna do. So afterwards, we do the same thing as before, and here I can illustrate what I meant. The standard deviation is 0.5 in the winner variable because it's either 0 or 1, and we have exactly 50% of the variables are going to be winner and 50% of them are going to be loser. So that's why we have a standard deviation of 0.5. And you see here that, for example, is this bonus armor penetration percentage, we have a 0.0 in the standard deviation. What's that mean if you have a zero standard deviation in a column? If you guessed that it's a constant variable, then you're right, because if it never deviates from anything, it's always the same value, right? So this variable is actually useless. This variable is actually useless as well. And the armor penetration flat also has a 0.0 here. It's also going to be useless. And we're going to get rid of the constant variables as well. As a rule of thumb, always remove the constant variables and identify variables. And that's what we do here. We just drop the columns that we talked about. Cooldown reduction is also 0. And then the identifier, the match identifier. Right. And, this process below is just the same. I'm just performing this train test splitting. I'm just displaying the column. I'm creating a tabular dataset object, but I'm specifying now that the label is going to be winner because it has to be also in capital letters. It has to be the same as a column name. I'm just going to store this in another directory. Okay. And now I'm going to specify, since this is the model that we're going to actually use in real life, in League of Legends, I'm specifying a time limit of 120 seconds instead of 60. So I want my model to be trained for 2 minutes instead. And the thing with this is that the more time you spend, the prediction time is also going to be higher. But I mean, it's also worth it. So I mean, it's a trade-off. It's a trade-off in the end. And now I do the same thing as before. I took the liberty to comment this out. If you're interested, I commented this out because the last days I was trying this and the leaderboard got stuck, and it actually didn't get stuck. It's actually because I had specified here a time limit of 6,000 seconds. So my models were actually huge. And this leaderboard took like 15 hours to print. So I just commented this so that we don't get stuck here for 15 hours. But yeah, I mean, you can print this out and you will get like the same thing that you get here, which is like a leaderboard of the best performing models, and then the feature importances as well. And the same goes for here, right? I have my data here. I create like a test object, and I just give it, and it tells me, okay, I'm 60% sure or 40% sure that this value is going to be a loss. things that are really interesting is that the model that we have created here is, well, the best performing model is going to be, I believe, like light GBM or weighted ensemble. This model, in this case, and it has chosen like 5 different categories. So if it were a decision tree, it would have 5 branches, because it's always, this model is always returning either 100% probability, 80, 60, 40, 20, or 0% probability of how sure the model is about this prediction that we're doing. And yeah, let's see if everyone has questions, and let me show you the last part of this Hasan lab. So here I created this what now? What do we do now with this information, right? We've deployed a model, we've extracted some conclusions, we've trained this, but what do we do? What do we do now, right? So my idea is to integrate this model, or this is called, sometimes some people like to call this model inference as well, which is to get the model out of a notebook. Just a lot of data science practitioners, they create the models to solve a problem, but then they don't make use of these models. And that's what I want to, kind of demystify, because it's not that hard. And I created some Python code, two clients. One is going to be a producer and one is going to be a consumer. And the idea is to get the producer to generate data and the consumer to consume it. The consumer, in our case, is going to run the data that the producer gives. This is going to be like League of Legends is feeding the producer some information. I get the producer, I pass it to the consumer scans this information through our machine learning model. It returns some information like, oh, you're most likely winning right now, and then display this. And this is, for example, a GIF that I created just to show you the final, Python code, which is this. You get this here. You have some timestamps. Since the prediction time is really low, in our case, you have here like every second you're making like 2 requests, 3 requests. I was playing a match with Ezreal, and through the live client API, like I said, you can extract a lot of information. For example, I can know that I'm playing Ezreal here. I can also know that I'm on Team Blue. And then I created like a dictionary which tells, which says, for example, 100 average prediction and 100 average probability. The average prediction itself, it joins up in a sliding window. So I have 100 predictions that have been made, the most recent ones, the 100 most recent predictions, and I'm just sliding them through time. So if I have 101, then I'm always deleting the first one and I'm adding it to the end. So it's like a queue, right? I'm just using this sliding window to make an average. So for example, in fintech, you have 100 moving average, 100 SMA, and some of these complex statistics, they work very much the same as this. They just use a different range, and they use days instead of seconds. But the idea here is that it's telling me, oh, it's a 0. From the 100 last requests, you're probably losing right now. And the average probability is just the average probability of my win or loss. I would show you the code, but I'd rather show you in practice so that you see it. So give me 1 second. Stefan asks, does ML predict the win-lose result based on the entire team's results or the individual player? Well, in this case, really good question, actually. Our dataset has been comprised of information like this. So for example, let me see a sample of data. So as you hear, you have statistics, for example, the magic resistance, the health regeneration rate. But for each one of the rows, you only have information from one player, right? So the machine learning model, this one, will just focus on yourself. You won't get any information from your companions, I mean your teammates or your enemies either. So this is just going to be a statistics or a hero stats based model, and this is going to be individual, right? But of course, you can expand this, and some of the things that you can do is get this and multiply by 5. So get 5 times more columns that we usually get, and just consider like, oh, I have my group of columns for player 1, then my group of columns for player 2, and just get 5 times or 10 times as long, and just generate another data set like that. That's another solution if you wanted to design or architect one of these models for everyone. In the current match model, we assume that the better stats, the higher chances to win. By different champs use different stats, shouldn't our model weight them differently? Like mages that have a higher AP, CDs should have higher chances to win than having high armor or crit chance. Very correct. Of course, if you have enough data, this information or these variances that you have are very slight, right? But through the course of a game, they become more apparent, right, Francisco? So at the beginning, of course, the model is going to be more shaky, of course. And what you could do to fix this, if you wanted to, and I invite you to try to do this, you can actually add another variable to the model, which is the champion name. And if you add the champion name, then all the statistics that you're going to have, the model is going to learn, okay, this is a variable that if for example, if I'm playing a top laner, I'm of course going to have more health than an AD carry, for example. So yeah, you could add, so for example, you could also add the role of the player, like you've said. That's actually a very good idea as well. Yeah, so let me reshare my screen. Is that good, Francisco? You have more questions, or because I like your idea. Tushar asks, if we use identifier column and use feature engineering to get match ID, can that help machine learning to predict win or lose better? Or in general, there is a different data set for match predictions. The match prediction, I mean, I would say that the identifier variable never adds anything. And I'm not usually a depressed person, but I think that I mean, a variable like the identifier, it has 500,000 different values, right? So it's never gonna give you anything, since 30 or 50% of the models, sorry, of the rows, they're actually different. So I wouldn't see how that can add any information to you. You know what I mean? And yeah, let me tell me if you can see myself. I created this. You have all this code in GitHub, of course. Oh, sorry, I'm not in the right directory. Yusuf, what was the dataset size which took 15 hours? What was your instance resources? I believe I was testing with 4 CPUs, 16 gigs of RAM. I used a standard E4 Flex instance, and dataset size was 2.4 million rows in our case, for this case. Okay. Let's see. So right now, let me put this a little bit. I probably it's gonna be a little. I don't know if I can zoom in this. I don't think I can. I don't want to break it. 1 sec. Settings. Fonts. I want to, put it bigger for you guys. There you go. Font 32. Save settings. Okay, so on one hand, I have my producer, which is making HTTP requests as I'm playing the game. So I'm playing Ezreal right now. You can see that I'm 3 minutes into the game. I haven't bought any item. And this is just returning a huge JSON object every 0.5 seconds approximately. And this is telling me, like you see here, that the game time is 192 seconds. So this is exactly in real time right now. I also have my events time, and I also have some information about myself. But with this information, this producer is sending this information to the consumer. The consumer is getting this information, it's running it through the machine learning model, and it's running 100 moving average for winning probability and the prediction. So right now, the model was thinking that I was winning, but now I'm starting to, the model is starting to get a little preoccupied right now. Not preoccupied, worried is a right word, because I have a 740 gold and I haven't bought any items. And you know, here at the bottom, I have 67 attack damage, for example, 30 armor, 30 magic resistance, 325 move speed, but I haven't bought any items. Usually you get 300 gold at the beginning or 400. Now I don't even remember. But for example, Carthus, which is my enemy right now, he has a Tear of the Goddess purchased and some health potions. And this Tear of the Goddess is giving him more mana. So right now he has more stats than me, right? Right now I'm a little behind with Ezreal. So I want to illustrate, like, okay, the model right now is thinking that I'm winning, and this of course changes over the course of the game, but I can actually like make a little exaggeration for you guys. So here I'm on a practice tool, so I can add myself some gold, for example. I'm gonna give myself some gold. And with this gold, let's see, 100,000. I'm gonna buy my, you know, my full build, for example. So I'm just gonna buy 24's Manamune. You know, the most expensive things that you can find. I'm just gonna purchase some of them, like that, and then the Reminisce Hydra, for example. So right now, my stats are all over the board, right? I had 67 damage. Now I have 344. Right now, this is full build. This is the build that you would actually get like 30 minutes into the game. You see here that after some time, the 100 moving average is gonna, you know, turn towards us, since our stats are all over the board. So this number is always gonna keep increasing right now until it goes to 100%. If I sell my items again back in the shop, if I sell all of them, then the model is gonna say, oh, like, what the hell? I'm 6 minutes in, I have no items, and I'm just gonna go back down, back down, back down, back down. And if I do the same with my XP, so my experience, so if I add some level, add some experience for myself, how did you do this? Level up. So if I level up my champion, I can't undo this, unfortunately, but you know, with more levels, you also get some extra attack damage. So now if you bought everything that you bought before, like here, and then you started playing, I'm just gonna run through mid lane, get some farm while I'm explaining this. But yeah, the idea is that this model, what I wanted to show you is that this model is reactive, right? Now it's changed. It was thinking that I was losing, but now it's thinking that I'm winning, and I'm winning hard according to my statistics. And since the model is based off of statistics, then of course this is what the model is going to think about. I just wanted you to show you, you know, kind of how these things can work. It's not that hard to get a model into production, as you have seen. It hasn't taken a while for us to do any of this. It's a very simple project. It's just a proof of concept, just to show you that open source is the future, actually. And at OCW, we're making like OCW, sorry, that's an event. At OCI and Oracle as a whole, we're making a real effort on trying to, you know, get people closer to machine learning. We have a lot of products like OCI data science, object storage, compute, Cloud Shell, hundreds and hundreds of ways in which you can do this. And I mean, if you want to check out the code, this you see here that you have a lot of files. This is the repository, the GitHub repo. You have a link here in the annex on the workshop tab. It's going to be the WebSocket consumer and WebSocket producer because they communicate through WebSockets. That's why I give it this name. And yeah, I just wanted you to, if you want to try this hands-on, you have this this part here. You will need to export, of course, your directory that it generates automatically, right? So you need to export this in some way. What I like to do is just to zip it inside with a terminal. So I go into my terminal. My Chrome is crashing, I think. Yeah, it's not responding. Well, I mean, you have all the instructions in the lab, and let's see. Someone asked, I guess maybe if you track player by ID or name and get enough data over time. Yeah, like the idea is that if you have infinite data, then you will have perfect artificial intelligence, right? That's if you had 100,000 matches for each one of the players, then you'd be able probably to create a perfect model for each playstyle. The thing is that one of the things is that we are rate limited by the Riot Games API. So we can now only make like 5 requests every 60 seconds or something like that. So generating the data set is probably the most time consuming part of this hands-on lab. But I mean, we're already giving you the data set, right? So you don't need that much to do yourself. If you want to try this at home, just execute the producer and the consumer at the same time. And one of the constraints of this that I'm talking about is that the League of Legends API, like we're doing here, League of Legends API, it only allows you to make requests in the same place as you are playing. So what I mean by this is that you can't make these requests, these web socket requests, if you're you can't make them on the cloud because it asks for locality, right? You can only make this request if you're local host, and then you're making the request to yourself. So that's one of the bad things that I would say that you're gonna find. So Stefan says, I'm guessing it would also be possible to create a user interface that could show us a simple overlay with the winning chance. Right. You could actually do whatever you want with this. I'm just displaying it in the console because I really like, proofs of concept like this, that you can actually display this. But you can, for example, you can spin up an OCI instance with a web server, for example, and then just have this information available through WebSockets, REST API, HTTP requests. You can have your own website, and through some JavaScript, you can modify any HTML tag and put this value in real time. They're like possibilities are actually infinite, and it's sad that we have limited time in this earth, because otherwise, I mean, I wouldn't stop doing things like this. So yeah, I mean, possibilities are infinite. You can do whatever you want with this data. You could actually like create a model that create another machine learning model that is able to learn with reinforcement learning, for example. It tells you, okay, this model has made accurate predictions. I'm gonna weigh all the things that I've done. Oh my god, I'm getting ganked. I'm gonna weigh, and I'm gonna say, okay, if I'm playing Carthus, for example, I'm gonna have like a decision multiplier. Or if I'm playing another character, then my decisions are gonna be, more important, less important, etc. Summer asks, can I run the same code on a local installation of AutoGluon, not on the cloud? Yes, you can do that. That's what I did actually. I created, my conda environment. I always like creating different conda environments for everything. So you need to install this requirements file. You have everything on the guide, but you have the requirements file, and if you install the dependencies, everything is should be ready for you. You just need to export your AutoGluon model locally, and it's about 2 gigabytes or 1 gigabyte with the things that we've done. So I mean, you see that you start to understand the importance of having good storage and a lot of storage available for these kinds of things, because models actually get quite complex. I hope everyone liked this presentation. Make sure to check out our future events in LinkedIn, also in developer.oracle.com, and Tara has also sent some links in the chat for that. We'll have another hands-on lab for League of Legends. We're gonna make an introduction for neural networks if you're interested. So yeah, just stay tuned on LinkedIn and things like this, and we'll see you guys.